So, geometric series. All right, now when it comes to geometric series, some books write this in slightly different ways, but the way I've always preferred it is that the sum n equals 0 to infinity of r to the n equals 1 divided by 1 minus r. Now if the absolute value of r is less than 1. All right. And now this leads us to a classic problem, which is Zeno's paradox. Okay. So say I have some distance that I have to cover, and we'll call that d. Okay, so now I cover half of my distance, I cover half of the remaining distance, half of the distance beyond that, half of the distance beyond that, half of the distance beyond that, half the distance beyond that, and I just keep repeating myself, okay? And so what Zeno's paradox was is before we really started incorporating it, this is a very, very old paradox. And so before we started using infinite series and limits and epsilon delta definitions, all that stuff, this was a real question. And I asked students in class about this. If I asked them if I cover half the distance to the wall, half the remaining distance, do I get to the wall? And the majority of people will say you do not get to the wall. Well, let's see what this infinite series actually converges to, okay? So, how do I turn this into an infinite series? Okay, I've got my distance, I'm covering half of it, and then I'm covering a fourth of it, then an eighth of it, d divided by 16, plus d divided by 32, plus dot, 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 dot. Okay. Now, all of these have a d on it. Okay, so I could say that's, well, d times 1/2 plus 1/4 plus 1/8 plus 1 divided by 16. Dot, 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 dot. Okay. Now I want to use the formula for geometric series for this one. Okay? But I got a problem. This one is actually starting at 1/2. This is where it's really important to pay attention to your indices, right? So the exact definition of the geometric series okay? It's really important to pay attention to that n which equals 0 right there. Right now, if we start the infinite series at n which equals 0, what are we going to end up with is whatever number we have in here. In this case, it's going to be 1/2. Well, 1/2 to the 0 is really 1, okay? So I have to actually begin with 1 if I want to use this formula, okay? So what I can do is I can say, all right, why don't I pull a 1/2 out of everybody, okay? So this would equal d divided by 2 and then multiplied by 1 plus 1/2 plus 1/4 plus 1/8 plus dot, dot, dot. Okay? All right. Now, this would equal d divided by 2 times the sum n which equals 0 to infinity of now 1/2 to the n. Okay? And so that would become d divided by 2 times 1 divided by 1 minus 1/2. Okay, Okay, 1 minus 1/2 is 1/2, so that's d divided by 2 times 1 divided by 1/2. Half. And so, you do cover that distance. Okay? So Zeno's paradox is no longer a paradox. When we talk about convergence, we're saying, okay, I'm coming infinitely close to this thing. I can tell you exactly how many steps you got to take until you're within a millimeter of the wall. And so we say, yes, you converge to that. So the sum of that is the distance. Okay, so Zeno's paradox is no longer a paradox.